Hi, today we're going to talk about how to multiply expressions that contain radicals. We are only doing these with numbers, not variables, but the rules are the same regardless. So if you are trying to look for help with radicals, with variables, inside it's going to be the same. All right, so the steps are really simple. You're going to multiply the outside numbers, you're going to multiply the inside numbers, and then you're going to simplify the expression. So here in general terms, in variables, we're going to multiply the outside, the number outside the radical, a times b. And then we have our radical, and then we're going to multiply the numbers inside, c times d. All right, that's how it works. So now let's look at some examples. All right, the steps again are multiply the numbers on the outside. Well, these don't have any number on the outside. Of course, that means that there is an implied 1 there, and 1 times 1 is 1. Then you're going to multiply the numbers on the inside. 2 times 10 is 20. Okay, and then the step 3 is to simplify. So we want to make sure this is in simplest form. The way that we've done it in our class is we've made a factor tree. So 20 could be 2 times 10. 10 is 2 times 5. Now you have your prime factors. So we rewrite the problem 2 times 2 times 5. And then if there are two of the same, then they go out. So 2 root 5 is the answer. Let's look at number 2. Number 2 actually has those numbers on the outside. So we're going to start with that. We need to multiply the numbers on the outside. 2 times 7 is 14. We're going to multiply the numbers under the radical. 5 times 3 is 15. Okay? Just a reminder that if these radicals have different indexes, if this one is blank, so 2, and this one is like a cube or a 3 or 4, another number up in the radical, then you can't multiply them together. All right, next we need to look into simplifying this expression. 15 is 3 times 5. There are no repeats. There's not two of the same. So the simplest form of this expression is 14 root 15. All right, number 3 is kind of a big one. So let's follow the rules. Keeping in mind that the multiplying parts, we're going to use the order of operation. So we can't add these two chunks together until we've multiplied and simplified. All right, so let's see, maybe we can't. First, 8 times 9 is 72. 27 times 3, the numbers inside, is, let's see, 20 times 3 is 60, 7 times 3 is 21, so 81. All right, plus, now we're going to look at this part. 6 times 7 is 42. Root 40, 8 times 5. All right, so at this moment, these two expressions cannot be combined because their numbers in the radical are different. But we still have a step to do. We still need to simplify. Now for me, and when I look at this, I immediately recognize that 81 is a perfect square. So this is going to be 72 times 9. All right. If you don't see that, if that doesn't jump out at you, then you would have proceeded like this over here. You would have taken your 81 and made a factor tree. 81 is 9 times 9. You could have even gone all the way down to prime numbers, prime factorization. Then you would have 3 times 3 times 3 times 3. And you're going to pull out groups of 2. And 3 times 3 is 9. So you can see, obviously, memorizing that 81 is a perfect square is a much simpler way than doing prime factorization, but it works both ways, so no big deal. All right, plus. Now we're going to do the 42, but we need to simplify, and I'm going to do it out to the side, the factor tree, because I kind of ran out of room. 40 is made of 4 times 10. 4 is 2 times 2. 10 is 2 times 5. So we have 42, 2, 2, 2, 5. All right. The 72 times 9 we could actually do, I'm just going to do it like this. 72 times 9 equals 648. But we still need to finish simplifying this. So we have our 42 and a group of 2 that goes out front. And inside, we don't have any more groups of 2, so we still have 2 times 5 there. 648 is done. 42 times 2 is 84. 2 times 5 is 10. And this is actually the final answer because we can't combine these two. We cannot add them together because this doesn't have a square root of 10 and this does. Remember, we can only add them together if their radical is the same. All right, one more. This problem should make you be like, oh yeah, that is a distributive problem. All right, you do need the distributive property, and that involves multiplying. So you are going to follow the rules of distributing and the rules of multiplying radicals. So the first thing we're going to do is 2 root 5 times root 6. Since root 6 doesn't have a number in front, there's an imaginary 1. So 2 times 1 is 2. Radical 5 times 6 is 30. Plus. Now this 2 does not have a radical. That's okay, we can still multiply. So we're going to do 2 times 2 is 4. And the square root of 5, and there's nothing there, so it's 4 root 5. And then we need to simplify. So 30 is made of 5 times 6, and 6 is 2 times 3. And see how there are no doubles? There's not 2 of anything. So that means that we can't take out anything. There's nothing to go to the outside. So the actual answer is 2 root 30 plus 4 root 5. All right, I hope that was a good review, or, maybe the first time you saw it, and have a good day.